Hi everyone, welcome back to freepilotgroundschool.ca. This is the third lesson of flight operations. We're going to be discussing wake turbulence. This is actually a pretty short lesson, but there's a lot of questions that show up on sample exams, so we're going to go through a bunch of them just to get you ready for that. So what is wake turbulence? Wake turbulence is caused by wingtip vortices. Wingtip vortices are a vortex of air that travel from the bottom of the wing to the top of the wing at the wing tip. And so that means the right wing, the air is going counterclockwise. The left wing, it is going clockwise. The wingtip vortice is a byproduct of lift. If you want lift, you are going to have a wingtip vortice. And it's actually quite interesting. If you had a way of measuring the strength of a wingtip vortice, you could exactly calculate based on various mathematical description of lift involving what's called a vorticity. And I don't want to get into it too much, but if you figure out the line integral of that vortex, you could determine exactly how much lift that wing is producing. So whenever the wing is producing lift, there is a wingtip vortice. Whenever there's wingtip vortice, you get wake turbulence. Therefore, wake turbulence begins with rotation and ends at touchdown. It is most pronounced clean, slow, and high lift, such as takeoff. Helicopters have similar vortices as fixed-wing aircraft when they're traveling in similar wake turbulence. The effects of wake turbulence, probably most pronounced, is, well, turbulence. You can have high rates of roll if you get caught in one vortex, and a slight crosswind can result in a vortex, one vortex sitting over a runway, and not only will you have turbulence, but you will have pronounced rate of roll. Now you might be wondering, well, how strong is wake turbulence really? Well, it is very strong. Several accidents have been caused by aircraft getting caught in wake turbulence and becoming rendered uncontrollable. I was flying a 737 one time behind another medium aircraft, Airbus A320, I believe. Air traffic control applied the proper spacing, and I took off, engaged the autopilot, entered wake turbulence, a vortex, and the rate of roll of the vortex exceeded the rate of roll of the autopilot, and the autopilot provided me a warning and I had to recover manually. That actually happened on 2 occasions. So that's pretty impressive when you think a 170,000-pound airplane can get rolled right over to the point where the autopilot cannot correct for it. Remember that wake turbulence avoidance is always the pilot's responsibility, even though air traffic control might give you a warning. Generally, the best way to avoid wake turbulence is to wait a minimum of 2 minutes if following a medium aircraft, or 4 minutes behind a heavy aircraft for the wingtip vortices to dissipate. If you cannot wait, what you can do is approach high and above the glide path, touching down after the touchdown point of the heavier aircraft ahead of you. If you're taking off, you can rotate prior to the rotation point and stay above the climb path. Let's review. Wake turbulence is caused by wingtip vortices. It can take 2 minutes or more to dissipate, and when it does dissipate, it dissipates slowly. It can cause extreme turbulence, exceeding the control capabilities of your aircraft. If you cannot wait this required amount of time, you can land above and ahead of a heavy traffic ahead, or take off before and above the heavy traffic ahead. Let's go through some sample test questions. Hazardous wake turbulence caused by aircraft in still air. A, dissipates immediately. No. B, dissipates rapidly. No. May persist for 2 minutes or more. That is the correct answer. Or D, persists indefinitely. No, it doesn't last forever, but it can be 2 minutes or more. C is correct. Which response is most correct with respect to wake turbulence? A, wingtip vortices are carried by the ambient wind. B, wingtip vortices have circular and downward motion. So both of those are correct so far. C, wake turbulence exists behind all aeroplanes and helicopters in flight. That is also correct. Remember, wake turbulence is caused by vortices, and vortices are a byproduct of lift. Therefore, the correct answer D, A, B, and C are correct. The wingtip vortices generated by a heavy aeroplane can cause a lighter aircraft encountering them to A, go out of control. Yes, it can. B, continue descent even when maximum power is applied. Yes, it can do that too. C, sustain structural damage. That is also correct. D, experience any of the above situations. D is correct. During the 2 minutes after the passage of a heavy airplane in cruising flight, hazardous wingtip vortices will A, dissipate completely. No, they will not. B, dissipate rapidly. Nope. C, dissipate very slowly. That is correct. D, remain at cruising altitude. No, they actually drop. So the correct answer is C. They'll dissipate very slowly. The correct answer is A, beyond the touchdown point of the other aircraft. To avoid wake turbulence when taking off behind a large aircraft, the pilot should. So remember, we want to take off before that other aircraft when there's no lift being developed, therefore no vortices and no wake turbulence. So A, remain in ground effect till past the rotation point of the large aircraft. No, that's a bad idea because you're going to go right through the wake turbulence. B, become airborne in the calm space between the vortices. There's not really a calm space between the vortices. C, taxi past the rotation point of the large aircraft, then take off and remain below its glide path. No. D, become airborne before the rotation point of the large aircraft and stay above its departure path, or request a turn to avoid the departure path. D is correct. Wake turbulence is produced by, so recall, wake turbulence is caused by vortices, and vortices are a byproduct of lift. So what vehicles produce lift? Well, all fixed and rotary wing aircraft. D is correct. Wake turbulence caused by a departing aeroplane is most severe immediately A, before rotation, B, following takeoff, C, above its flight path, D, following full power application. So before rotation, there's no lift being developed, there's no angle of attack. So A is not correct. Following takeoff, yes, that would be correct. C, above its flight path, no, because the vortices drop. D, following full power application. No, that's not correct. Wake turbulence is not the same as jet blast. Correct answer, B, following takeoff. Which statement concerning wingtip vortices is false? A, vortices normally settle below and behind the aircraft. That's true. B, with a light crosswind, one vortex can remain stationary over the ground for some time. That is also true. C, lateral movement of vortex, even in no wind condition, may place a vortex core over a parallel runway. That is true. D, vortices are caused directly by jet wash. No, that is not correct. Jet wash is caused by jet blast or thrust. Vortices are caused by lift. Therefore, the correct answer, D, that is false. Vortices are not caused directly by jet wash. Wake turbulence will be greatest when generated by an airplane, which is, so remember, it's directly proportional to the lift. When is an aircraft producing the most lift? Well, when it is heavy, when it's clean, taking off, and it's slow speed. B is correct. A helicopter in forward flight produces hazardous vortices. A, which rise above the helicopter. No, that's not correct. They always drop. B, similar to wingtip vortices. Yes, that's correct. C, which remains at the same level as the helicopter. No, we just discussed that vortices drop and ahead of the helicopter. I don't know how that would happen, that you'd have a vortex ahead of the helicopter. So B is correct. Which statement concerning vortices caused by helicopters is correct? A, helicopter vortices are generally weak and dissipate rapidly when formed close to the ground. No, helicopter vortices are not weak. They're not any weaker than in an airplane. The size and weight of the helicopter has a direct influence on the intensity of the vortices. Well, I think that would be correct. That's the same as an airplane. C, helicopter vortices are less intense than the vortices of an airplane of the same weight. No, that's not correct. Like we said earlier, vortices are directly proportional to lift, which is exactly the same as weight. So a higher weight for any aircraft will end up with the same vortices. D, wind does not influence the movement of vortices generated by a helicopter in hovering flight. No, that's not correct. Wind moves the vortices. So correct answer B. What effect would a light crosswind have on the wingtip vortices generated by a large airplane that had just taken off? A light crosswind, A, could cause one vortex to remain over the runway for some time. That's true because the vortices are carried with the wind. B, would rapidly dissipate the strength of both vortices. Nope. C, would rapidly clear the runway of all vortices. No. D, would not affect the lateral movement of the vortices. No, that's not correct. The correct answer is A. One vortex can remain over the runway for some time. That concludes this lesson on wake turbulence. Thanks a lot for joining us. You are now going to be doing a couple lessons on human factors, and following that, you're going to be writing your P-STAR exam. Thanks for joining me.